Systems of linear inequalities. Obviously, we've been working with systems of two linear equations, so now we're going to be working with systems of two linear inequalities. We know the four inequality symbols, they just replace an equal sign. And we're going to begin by reviewing how to graph one individual linear inequality. We basically graph it just like we're an equation. Begin by putting it in the slope-intercept form if it's not in slope-intercept form. But there's two additional steps for graphing a linear inequality. First of all, the line is either going to be a dotted line or a solid line depending on the inequality sign. Next, you're going to shade one side of the line or the other, determining where the solutions lie. So let's look at an example here. 1, y is less than or equal to 5x minus 4. Linear inequality already in slope-intercept form. So we can begin by graphing it. The y-intercept, -4, the slope 5, so up 5. To the right 1, but before we sketch the line we have to look at the inequality sign and see if it's going to be a dotted line or a solid line. Less than or equal to means it's going to be a solid line running through those 2 points. And now we have to determine what side of this line is going to be shaded, where the solutions to this inequality lie, on one side or the other. So the easiest way to do that is to choose a test point, and we have to choose a point that the line does not pass through. So of course the origin, the point 0, 0, would be the easiest point to work with. Substitute it into the inequality, it would give us 0 is less than or equal to -4, which of course is not true, so therefore our test point 0, 0 is not a solution, so no points on the left hand side are solutions to this inequality. Therefore the solutions must lie on the opposite side, so we shade that side. Another example, example 2, 2x plus y is greater than -6. Another linear inequality. We want to begin by putting this one into slope-intercept form, so all we have to do is subtract 2x from both sides. Now remember, working with inequalities, if you ever end up multiplying or dividing both sides by a negative, you have to remember to flip that inequality sign. But we certainly did not have to in this case. The y-intercept, -6. The slope, -2, so we run off the graph a little bit, down 2 to the right 1, or we go up 2 to the left 1, it doesn't matter. We know where the line is going to be, so we sketch the line, and in this case it's going to be a dotted line because of that inequality sign, strictly greater than. So we sketch the line passing through those 2 points, and now we need to shade one side of this line or the other. So once again we can use the origin since the line does not pass through it. If you substitute in the inequality, 0 is greater than -6, which is true. Our test point is a solution to the inequality, so that means every point on that side of the line will be a solution. We'd shade that side. So finally, putting these linear inequalities together in order to form a system of linear inequalities, and it's just going to be a system of two linear inequalities once again. The method we have to use in order to solve a system of linear inequalities is this graphing method. So all you do is graph each inequality together in the same graph. So example 1, take these two inequalities we just graphed, put them together to form a system of two linear inequalities. So the first one, of course, the y-intercept was -4, the slope 5, so we sketched that. The solutions were to the right of this line, but before I do any shading, for now I'm just going to put a couple arrows pointing to the right just to remind me where what side got shaded, where the solutions lie. I'm going to wait to the very end of the problem to do any shading at all. So that's the first inequality. The second one, what we just got through doing a few minutes ago, the y-intercept -6. This was a dotted line, and the solutions to this inequality were to the right of it as well. So just graph each inequality. So now that it's a system, we shade where the solution to the overall system will be the shaded regions that overlap. So that's the one shaded region we have on our graph now, showing the solution to this system. The areas to the right of the first inequality, and also to the right of the second inequality. So just this region would be the solution to the overall system. Example 2, system of two linear inequalities. The first one is simply going to be a vertical line through -4, since it only has one variable, but since that inequality sign is less than, it's going to be a dotted line, and all the values less than -4, of course, would lie to the left, so show that with a couple of arrows pointing to the left. The second inequality, begin by putting that in slope-intercept form. Y is greater than -1/3 x plus 2. So y-intercept 2, slope -1/3, so down 1 to the right 3. And this one is also going to be a dotted line. So sketch this dotted line. Determine what side the solutions lie here. We can use that test point 0, 0. If you plug 0, 0 in to that inequality, it is not a solution, so therefore the solutions lie on the opposite side above that line. So finally, really the only new step here, the final shaded region, solution to the system, is where these two shaded regions overlap. And looking at our arrows, they would simply overlap in this region kind of in the upper left-hand corner. So that's the solution to the overall system. And example 3, system of two linear inequalities. In this case, you only have the variable y, so they're both going to be horizontal lines. The first one, a solid horizontal line through -2, and all the values greater than it will lie above it. The second one, y is less than -5, so a dotted horizontal line through -5, all the values less than it. So the solution to the overall system would be where these shaded regions overlap. Well, of course, in this case, they're not going to overlap. Parallel lines will never touch or intersect, so these shaded regions will never overlap. So therefore, no solution to this system. So systems of linear inequalities, for the most part, will simply have infinitely many solutions. Most of the time, we'll have infinitely many solutions, but it is possible to have no solution as well, as we just seen.